By the end of this video, you're going to know how to solve every single parabola question and get a higher score on your next SAT. So there are 8 types of parabola questions that are tested on the SAT. Nothing else is literally just these 8. And whether you can solve these questions or not comes down to one simple idea. Because SAT in a nutshell is that it just gives you a question and it's asking, hey, which concept, which tool would you use to solve this question? And the hard part where most people get stuck is making this connection between the question and the concept. Which concept do I use to solve this question? In order for you to make that connection, you have to understand the purpose of each tool/each concept. And for 8 parabola questions, we're going to use what's known as the mental mapper, which is going to show you the 8 concepts, what their purposes are, and how these questions would actually look like on the SAT. And this is something we use inside the accelerator program to help students hit 700+, but I'm going to link it down below so that you guys can print it out, try it with me, and never miss another parabola question and get a higher score. So let's get started. So the first 2 types of questions are going to be testing you on your ability to find roots. So roots are referring to where the graph intersects the x-axis, also known as the x-intercepts. For the SAT, there are 2 ways to find them. You either factor the equation or you use the quadratic formula, but what is the difference? And the difference is that you use factoring when numbers are simple and the equation is factorable, but when the equation is not factorable, that is when you use the quadratic formula. So let's take a look at this example. The function above have 2 roots, a and b, given that a is greater than b, what's the value of a? So looking at this equation, we know that it is obviously factorable. Numbers are looking nice and clean, so I'm just going to quickly factor into x minus 10 and x minus 1, which means our roots are going to be at -10 and +1. Of the 2, 1 is greater, which means that's going to be the value of a. So when the numbers are looking nice and clean, you simply factor them. But what if they are not so clean and they cannot be factored? So for example, which of the following is the solution to the given equation? The solution is referring to the value of x that makes the equation true. In this case, we're looking for a value of x that makes our y value equal to 0. Value of x that makes the y equal to 0 is the x-intercept, is asking you to find the x-intercept. And by looking at the answer choices, we already see radical in there, which tells us that this equation is not going to be factorable. So we're going to go straight into the quadratic formula, which looks something like that. Which means our answer is going to be choice A. So the main takeaway is if the numbers look complicated or you already see radicals in the answer choices, plug it into the quadratic formula because it's not going to be factorable. But if the numbers are looking nice and simple, try to factor it out because it's going to be faster. But there's one more thing you need to know about roots, because sometimes they're not going to ask you to find the exact value. Instead, they're going to ask you, hey, what is the product? You see how we're not looking for the exact value of the x-intercepts? Instead, we're looking for the total product of the x-intercepts. In that case, you're going to use the simple formula of, for the product, you're going to use c over a, and for the sum, you're going to use -b over a. So in this case, our product is just going to be 8 over 1, so our product is going to be 8. And for the sum, it's just going to be straight out 4. So the main takeaway here is whenever the SAT asks for a product of the roots or the sum of the roots, then realize that, oh, this equation is not going to be factorable, so I need to go straight into the formulas instead. Does that make sense? And that's literally all you need to know about roots for the SAT. So let's go to the next 2 types, which is going to be testing you on vertex. Vertex is very popular, and you need to know the 2 separate ways to find out the location of the vertex. So the first is going to be using the formula of -b over 2a. And here's how it looks like on the SAT. A quadratic function f is shown above. For what value of x would the function obtain the maximum value? So we know that when it comes to a parabola, the maximum value is referring to the vertex, because if you graph this out, this graph is going to look something like this. Maximum is known as the vertex. And the maximum value, which is referring to the y value, is going to be where the vertex is located. And how do we find the vertex? We plug it into the -b over 2a formula. Why? Because we have our a, b, and c. We're given our a, b, and c here, so we just have to plug it in. -b, which is going to be -4 over 2a, which is going to be 2 times -7, which is going to be -4 over -7, 14, which is going to be just +2 over 7. That gives you the x coordinate of the vertex. And if you want to find out what the y coordinate is, just plug in 2 over 7 into this equation right here and find out what the resulting y value is. So when you are looking for the vertex, you use the formula -b over 2a when you are given the equation of a parabola. Because if you're not given the equation, how are you going to know what a and b and c are? Which is something you would need for the formula. But the funny thing is that SAT is going to test you on vertex without giving you the equation and ask you to find it. And here's how it works. So if you look at this question over here, in the quadratic function provided above, a and b are going to be positive constants, just positive numbers. If the function contains zeros at x equals 4 and x equals minus 6, what's the value of a, which is shown right there? So we know that it's going to be a parabola because of that 2 right there, and it tells us that it has zeros or x-intercepts at 4 and minus 6. So minus 6 over here and 4 right there. It's going to look something like that. And based on the information, we need to find out what our a value is. So the thing is, the vertex is always going to be located in the exact middle of the two roots. So in this case, our roots are going to be at minus 6 and positive 4, which means the exact middle is going to be at minus 1, which means minus 1 is going to be the x-coordinate of our vertex. And now that we know that, we can also plug that into the vertex formula. Remember, x-coordinate of the vertex can be calculated by minus b over 2a, right? And in this case, what is our b value? Our b value is that letter a right there. So it's going to be minus a over 2a. A is going to be number in front of x squared. It's not the same thing. So it's going to be just 2 times 1, which is going to be 2. And we know that the x-coordinate of the vertex is what? Minus 1. So we're just going to set it equal to minus 1, which means when we cross multiply, we're going to get minus a is equal to negative 2. Our a value is just going to be positive 2. Does that make sense? So the main idea here is that the vertex is always going to be located in the middle of the two roots. And you can use something known as the midpoint method, use the midpoint formula to find the middle location and come up with the x-coordinate of the vertex. Okay, so when you are not given the full equation, you can use the midpoint method to find out the vertex. But if you're given the full equation, then you can simply plug it into the minus b over 2a formula and find the x-coordinate that way. Does that make sense? Cool. So that's literally everything you need to know about vertex for parabola. Let's go to the next two types, which is going to be testing you based on the forms. So when it comes to a parabola equation right there are two equivalent versions of this exact equation, but they are just written in a different format. They're the exact same equation, they just write it out in a different way. Why do they do that? I don't know. Don't ask me. And what's important is for you to understand the purpose of each of these forms. So here's how the question would look like on the SAT. Which of the following is an equivalent form of the function g above in which the x-intercepts are shown as constants or coefficients? So we're given a parabola equation right there, and the question wants us to rewrite this equation so that the x-intercept of this parabola is shown as a constant. Constant just means it's just a number. So how do you show the x-intercept of the parabola as a constant? Well, that's when the factor form comes into play. When you rewrite this original equation into this form, if you factor it out and just write it out this way, then just by looking at this equation over here, we know that, our x-intercepts are going to be located at minus 5 and minus 1. So what is the purpose of the factored form? It is to show the location of the roots or x-intercepts as constants. Because when it's factored out like this, just by looking at this number 5 and number 1 right here, you know exactly where the x-intercepts are located. The x-intercepts are shown as constants, just straight out numbers. And if you look at the answer choices, C is the only one that is in the factored form. Does that make sense? Well, what if the question asks you for something like this? The equation above represents a parabola on the xy plane. Which of the following equation represents the minimum value of the function as constants or coefficients? So instead of x-intercepts, we now have to represent the minimum value of the function, minimum value of the parabola as constants. In this case, minimum value is going to be our vertex. So what they want us to do here is for us to restructure this equation, rewrite this equation so that when we look at the equation itself, we know exactly where the vertex is located. And that is the exact purpose of the vertex form. The purpose of the vertex form is to show the location of the vertex as constants. And the vertex form looks something like this, and h and k represents the x and y coordinates of the vertex. If you look at this example over here, we know that our vertex is located at minus 3 and minus 4. And if you go to this question over here, which one is in the vertex form? It's going to be choice D, because choice D represents the vertex as constants using 3 and 25 right here. Just by looking at the equation, we know exactly where the vertex is located. Does that make sense? Cool. So make sure you remember these two forms right here, factored form and the vertex form. And last but not least, the most popular type of questions nowadays, I think, on the SAT for parabolas is going to be testing you on something known as discriminants. And discriminant serves two purposes on the SAT. The first is finding the number of x-intercepts in a parabola versus finding the number of intersection between line and the parabola. So the question would look something like this. For what value of c would the function above have one solution? So we are given a parabola and we're looking for a solution. What's a solution? Solution is referring to the value of x that makes the equation true. And in this case, we're looking for the value of x that makes our y value equal to 0. So value of x that makes the y equal to 0, what is that? It's going to be the x-intercepts. Those are the x values where y's are equal to 0. So in other words, we're looking for value of c where the function would have just one x-intercept. And how do we know whether a parabola has 0, 1, or 2 x-intercept? That's where discriminant comes into play. Discriminant is known as this formula right here, b squared minus 4ac. And when this formula is applied just to a single parabola, it tells you the number of x-intercepts in a parabola. And when your discriminant is equal to 0, your parabola only has one x-intercept. So let's apply to this question. We know that discriminant is going to be b squared minus 4ac. And in this case, ours would have to equal to 0 so that it would only have one solution, which means 6 squared minus 4 parentheses minus 2 and then positive c, which gives 36 plus 8c. And we know that it has to equal to 0, which means our c value is just going to be negative 36 over 8, which is going to be 9 over 2. Does that make sense? So when c is equal to minus 9 over 2, discriminant is equal to 0, which means there's only one x-intercept, so that will be our answer. But what if the question is not just talking about parabola, but parabola and a line instead? So for example, in the coordinate plane, the graph of line and a parabola intersects at exactly just one point. If a is positive, what's the value of a, right? So when it comes to a line and a parabola, there are three possible scenarios. It can have two intersections like that, or just one intersection like that, or no intersection at all because they would never cross. And our job here is to find the value of a so that there is only just one intersection between a line and a parabola. And that's the second purpose of discriminant because it will show you the exact number of intersections between a line and a parabola. When your discriminant is set equal to 0, that's when you have exactly one intersection between the two graphs. So first, you're going to have to combine the equations and then plug it into the discriminant formula. So if we do the math, so the first step is to combine the equations. 2x squared plus 3x is equal to a. Move it to the other side and plug it into discriminants. And our discriminant is set equal to 0 because that's when you have just one intersection, which means our answer is going to be 9, 8. So the main takeaway here is that if you're looking for a number of x-intercept in just a parabola, you use discriminant. Or if you're looking for the number of intersections between a line and a parabola, that's when you also use the discriminant. And literally, that's every type of parabola question you will ever see on the SAT. If there's new things introduced, I'll update you guys on it, but that's it for now. So for your next SAT, make sure you understand and memorize the purpose of each of these concepts, and you'll get a higher score on the next exam, and I'll see you on the next video.